Hey there, tech enthusiasts. Today, we're diving into the world of PLCs, or programmable logic controllers. Imagine a brain that controls machines, making them work automatically. That's what a PLC does. It's like a mini computer designed specifically for industrial automation. PLCs are used everywhere, from factories to amusement parks, controlling everything from conveyor belts to roller coasters. They are robust and reliable, built to withstand harsh industrial environments. In simple terms, a PLC takes input signals from sensors and switches. It then processes these signals based on a program you create. Finally, it sends output signals to control actuators like motors, valves, and lights. Now, why are PLCs so important? Imagine controlling hundreds of machines in a factory manually. It would be chaotic and inefficient. PLCs bring order to this chaos. They automate complex processes, making them faster, safer, and more efficient. PLCs eliminate the need for manual intervention, reducing human error and increasing productivity. This leads to cost savings and improved product quality. Moreover, PLCs are flexible. You can easily reprogram them to adapt to changes in production needs. This adaptability makes them invaluable in today's rapidly evolving industrial landscape. Let's take a closer look inside a PLC, or programmable logic controller. Don't worry, it's not as complicated as it sounds. Once you understand the basics, it all starts to make sense. A typical PLC has 5 main components that work together to perform its functions. First, the Central Processing Unit, or CPU, which is often referred to as the brain of the PLC. It is responsible for executing the program and making decisions based on the input data. Second, the memory, which stores the program instructions and data. This is where all the logic and control sequences are kept. Third, the input module, which receives signals from various sensors and switches. These inputs can be anything from temperature readings to the position of a machine part. Fourth, the output module, which sends signals to control actuators, motors, and other devices. This is how the PLC interacts with the physical world. And fifth, the communication interface, which allows the PLC to communicate with other devices, systems, and networks. This is crucial for integrated and automated operations. These components work together seamlessly to automate complex industrial processes, ensuring efficiency and precision. The CPU fetches instructions from the memory, processes input signals from the input module, and updates output signals through the output module based on the program logic. This continuous cycle is what enables the PLC to control machinery and processes effectively. Now, let's talk about how to talk to a PLC. That's where ladder logic programming comes in. It's a graphical programming language that resembles electrical ladder diagrams. Imagine 2 vertical rails representing the power supply. In between, you have rungs, each representing a specific control action. The elements on the rungs are like switches and relays in an electrical circuit. Ladder logic uses symbols to represent different functions. For example, a normally open contact acts like a closed switch when the corresponding input is true. A coil represents an output, like turning on a motor. Section 5. Understanding inputs and outputs in PLC programming. Inputs and outputs are the bread and butter of PLC programming. They are how the PLC interacts with the real world. Inputs are signals received by the PLC from sensors, switches, and other devices. Think of them as the PLC's senses. Outputs, on the other hand, are signals sent by the PLC to control actuators like motors, valves, and lights. They are the PLC's actions. For instance, a proximity sensor detecting a passing object could be an input. Based on this input, the PLC program can activate an output to turn on a conveyor belt. Section 6. The scan cycle. How a PLC thinks. PLCs have a unique way of thinking called the scan cycle. It's a continuous process that the PLC follows to execute the program. The scan cycle has three main steps. 1. Input scan. The PLC reads the status of all inputs. 2. Program scan. The PLC executes the program logic rung by rung. 3. Output scan. The PLC updates the status of all outputs. This cycle repeats continuously, ensuring that the PLC responds to changes in real time. The scan time, or the time taken to complete one cycle, is crucial for fast and efficient automation. Section 7. A simple example. Controlling a motor with a PLC. Let's put it all together with a simple example to understand how we can control a motor using a programmable logic controller or PLC. Imagine we want to control a motor using a start and a stop button. This is a common scenario in industrial automation. First, we need to set up our inputs. We'll connect the start button to input 1 and the stop button to input 2. These inputs will send signals to the PLC. Next, we need to set up our output. We'll connect the motor to output 1. This output will receive signals from the PLC to control the motor. For the programming part, in ladder logic, we'll create a rung where the start button energizes a coil that represents the motor. This is how we tell the PLC what to do. The stop button will be normally closed, de-energizing the coil when pressed. This ensures the motor stops when the button is pressed. Now, when you press the start button, the motor will turn on. The PLC sends a signal to the motor to start running. Pressing the stop button will turn it off. The PLC will cut the signal, stopping the motor. That's the magic of PLC programming. It allows us to automate and control machinery with precision and reliability. Section 8. Common PLC applications in industries. PLCs are like the superheroes of the industrial world, used in countless applications across various industries. In manufacturing, they control automated assembly lines, robotic welding systems, and packaging machines. In the food and beverage industry, PLCs ensure precise mixing of ingredients, control pasteurization processes, and manage bottling lines. In the energy sector, they monitor and control power generation, transmission, and distribution systems. From automotive to pharmaceuticals, from water treatment to theme parks, PLCs play a vital role in automating processes, improving efficiency, and ensuring safety. Section 9. Getting started with PLC programming. Tips for beginners. Ready to embark on your PLC programming journey? It's an exciting field with endless possibilities. Here are a few tips to get you started on the right foot. First, get a good understanding of ladder logic, inputs, outputs, and the scan cycle. These are the building blocks of PLC programming. Second, the best way to learn is by doing. Theory is important, but practical experience is invaluable. Use a PLC simulator software or a training kit to practice programming. These tools allow you to experiment without the risk of damaging real equipment. Third, divide your program into smaller, manageable sections. This makes complex tasks easier to handle and debug. Fourth, document your code to make it easier to understand and troubleshoot. Clear comments and notes can save you a lot of time in the future. Fifth, try different approaches and learn from your mistakes. Don't be afraid to experiment. Remember, practice makes perfect. With dedication, persistence, and a thirst for knowledge, you'll be a PLC programming pro in no time. Keep pushing your boundaries and stay curious. Section 10. Conclusion. The future of automation with PLCs. As technology advances, PLCs are becoming even more powerful and versatile. The future of automation is intertwined with the evolution of PLCs. The Industrial Internet of Things, or IIoT, is enabling PLCs to communicate with each other and with cloud-based systems, paving the way for smarter and more connected factories. Learning PLC programming is an investment in a future-proof skill. With their wide range of applications and endless possibilities, PLCs will continue to shape the landscape of industrial automation for years to come. So, dive in, explore, and unlock the exciting world of PLCs.